Good morning. Today we discuss the class, the Maxwell-Boltzmann statistics. Maxwell-Boltzmann statistics. This is a very important question. That one. So Boltzmann statistics. This is film question is important. Boltzmann statistics presents. So there is basically two type of the particle. This is Maxwell-Boltzmann statistics method. This one, the basically two type of particles. One is identical and distinguishable. Second one is identical and indistinguishable particles. So that is two particles, two type of the particles. First particle, the first type of the classical statistics, first of the classical statistics called as maximum. The is applied the will second type of the particle make use of the statistics, quantum statistics. That one Bose-Einstein and Fermi-Dirac statistics. Fermi-Dirac statistics. For classical particle, we now employ the Maxwell-Boltzmann statistics and the distribution function. So basically two type of the particles, the identical and distinguishable. Second one is identical, indistinguishable. The particles of two types. One is the first typical classical statistics, that is Maxwell-Boltzmann statistics. Second particle used for the quantum statistics. Bones, Bose-Einstein and Fermi-Dirac statistics. For classical particles, we now employ the Maxwell-Boltzmann statistics, the distribution function. That is, in the Maxwell-Boltzmann statistics, there is restriction on the number of particles and the same energy state. Let us consider here let us consider an assembly of n particle, capital N particle, that is capital N particles. capital N particles, and microstate specified by the occupation number occupation numbers occupation numbers occupation numbers n1 comma n2 comma n3 dash 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 nj nj. So nj the degenerate of the levels are the degenerate of the levels are degenerate levels. Which one? Levels G1, G2 dash dash G1 comma G2 comma G3 dash dash GG GJ. Okay. So as the particle is the two arrangements are considered the different is level it contains of contents of different particles. The first particle may be placed in the one of the one of the GJ state. Second one is there is the restriction on the number of particles any state. The second particle can be also the placed in the one of the state GG one of the state GJ. So the providing the total of d g I g j square total the providing the state providing the total state is equal to gj square gj square. Okay. So the gj square the two particles first one is and second one is two particles, that is gj square. So here nj square here nj square the particles in the level the total number of possible distribution level is w j is equal to wj is equal to gj gj nj. That is the formula. The distribution in the level is, that is wj is equal to gj and nj. That is the formula. So this is for example three states. This is for example we take the three states. There are the three states for nj. Three states for nj is equal to 2. Nj is equal to 2. That is two particles. 2 means two particles. The possible arrangement of the particles is the possible arrangement of the particles is 3 square. Is 3 square. That is 9. So that is 9. 3 arrangement is the particles. That one. So according the formula, which is the three states is divided the three states. First one and two. There are three values there. The number of the total number of the distribution, total number of the distribution, the microstate and Maxwell Boltzmann Einstein, and second one is what? Fermi, Bose Einstein. Third one is Fermi Dirac state. So that is three states. That one. So here first you write the states. First you write the state. Write the states. One, two, three states. This one three states. So states, first one is first state Bose-Einstein. Second one is first one is Maxwell-Boltzmann. Second one is Bose-Einstein. Third one is Fermi-Dirac. Fermi-Dirac states. So that is the value. The states first one to is a which one? 3 square. 3 square is equal to 9. That value write first states 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the value states that. So here only two states, that is equal to Ng. So three states, if I consider the value, Ng is equal to 2. So which one is the occupation of the numbers and the degenerate of the levels? We both values this one and this one. So that is equal to N2. So two particles. That value you write two particles mean, for example, A, B. A comma B. Next to that value, right? First state, we take the readings A, B. Okay. So second state value also 2 square. So 2 square means 4. So first state value 2. Second state value is 2. So that value is value. We write the second state. This value here A. There is A B and here A B. So next value only take the value occupation of the numbers. That value Maxwell-Boltzmann formula. Maxwell-Boltzmann formula, which one? Only A. So for first particle, this is the two particles mean AB, three particles mean ABC. So only single particle is A. So that value you write the value third state. So third state value total is 0. So next one, fourth one is only Maxwell-Boltzmann. So that is Maxwell-Boltzmann value only first state and second state. So that value two values there. So two values, which values? Only single particle. Single particles is also first state value is A. This is 0, amma. This is 0. This is 0. There is also both values is 0. Okay. Fourth one is here. This is A. B. There is 0. Okay. So next to fifth one. Fifth one is also only two states, that one. That is also fifth one here. A B. A B. Next to similarly same. Sixth one is also A. Here is single particles, individual particles. That is A. First particle A. Second particle is B. Okay. Next to seventh one. Seventh one, that is also same. Here is single part set. First we convert the commutative formula. Commutative formula is also here. First state is B value. Second state is A value. Okay. So next one, eighth one is same here. This is 0. converted to second state and third state. So here is A, here is B. Next to this is also commutative. Third was this value is also commutative value. Here which value? This is 0 same. Here is B. Here A. This is the formulas is state that converted to the states. So this is the classical assumption of the equal regions of the phase space. The theoretical equality probabilities is replaced by the assumption that each quantum state theoretical equally the possible. The state is driven by importance importance of the cells. That is a system having the system having the n small n value. System having n value n value n value the n value the identical particles the identical particles the identical particles n1 n2 dash dash ni the identical particles of n1 comma n2 comma dash dash ni ni particles. The energy energies energy is equal to E1 comma E2 comma dash dash EI 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 the respectively the GI is the statistical weight of the quantum group. GI, which one is the GI? So GI here GI is the statistical weight of the quantum group. The condition of the Maxwell-Boltzmann statistics. That is four points. That one. That is the 4 point is. So first point is the particles of distinguishable 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 the symmetry no symmetry restriction exists. Second one is the total number of the particles in the entry of the system is so- always constant. That is summation ni is equal to n capital N. It is equal to ni is equal to capital N. So third one is the each eigenstate of the quantum group contains 0 comma 1 comma n particles. N eigenstates eigenstates 0 comma 1 comma dash n particles. N particles. That is fourth one is summation ni ei is equal to fourth one. This is third one, second one, and first one. Okay. So fourth one summation ni ei is equal to ni ei is equal to summation ni ei is equal to g g. Okay, so that is the energy of the all the particles, all the particles, the different quantum groups, the different quantum groups taken, the together is equal to the total energy of system, total energy of system. The quantum groups taken that together is the equal to the total energy of system. So here the suppose the first the choose the ni particles, here ni the particles, the ncnl, the number of the base, the number of the base, the number of the base, this is equal to NCN NCL NCNL NC NCNL. So here NCL here NCL NCNL NCNL is equal to 1 by 1 by 1 by N1 N1 factorial minus N1 into 1 factorial. N1 factorial. So similarly, the number of the base, choosing the N2 particles, the N2 particles, N2 particles, N2 particles, out of N2 particles out of N minus N1, N minus N1 particles is particle is particles is particle is N1, sorry, N minus N1 into NC1, NC, sorry, NC2, here is NC2, this is only NC1, this is first one is NC1, there is NC2, okay, NC2 is equal to 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 n factorial by n factorial by n factorial by n factorial by n2 factorial minus n minus n1 minus n2 factorial, n1 minus n2 minus n2 factorial. Here n minus n1 into n minus n1 into nc2 is equal to n factorial by n2 factorial into n minus n1 minus n2. That is n2 particles. This is n2 particles also. You write this one. There is n1 particles only. First one is only n1 particles. Particles is this formula. N2 is this one. So we both equation the total number of ways. The total number of the ways here. The total number of the ways which is the particle is a different states. Different state maybe exchange is ncnl ncnl. The total number of the ways the different state be the different state maybe exchange is ncnl is equal to ncnl is equal to n minus n1 into nc2 is equal to nc2 is equal to nc2 is equal to n factorial by n factorial n1 factorial n2 factorials n2 factorials that is dash 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 ni factorial ni factorial. That is the ni the particles. That is the total number of the particles. The total number of the particles that is ncnl is equal to ncnl is equal to that is not is equal sorry ncnl into n1 n minus n1 into nc2 is equal to n factorial by n into sorry n1 factorial n2 factorial this is right sorry n1 factorial n2 factorial n3 factorial dash ni factorial. So the each group of the level is GI elementary waves function. GI elementary waves the functions. The functions are available. Consider the eighth group eighth group eighth group eighth group. The particles are accommodate in G1 different group. G1 different group. The first Ni can be accommodated in GI ways. GI ways. All the Ni particles can be occupied in the GI group. GI group is GINL ways. GINL ways. So that is the total number of eigenstate of the system. The eigenstate of the whole system is given by G is equal to capital G is equal to capital G is equal to n factorial n factorial n factorial G1 n1 G2 n2 dash 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 GINL GINL by by this n1 factorial n2 factorial n3 factorial this value amount. That is ni is equal to this total value there. So that is equal to so n1 factorial n2 factorial n3 factorial dash dash n I factorial. N I factorial. So is equal to this is this total value Ni Gi is equal to GINL GINL GINL. This value is equal to n factor Ni factorial Ni factorial. So you write this value G is equal to, that means its total value is a Ni factorial total value is equal to pi capital pi pi I I by GNL value, the numerator and denominator value is equal to GINL by Ni factorial. That is equation. The Ni factorial. Now the probability of is given state. Probability of is a given state. W is equal to W is equal to n factorial. Here W is equal to n factorial capital pi I G I N L by Ni factorial. Ni factorial. That is the constant. Constant. Okay. So that is constant. You find out you multiply the log. Multiply the both side is log. Applying log. So log W is equal to this is convert the value. W is equal to log n factorial is equal to log n1 factorial into the log factorial. You are multiply this value log a by b formula. Log a by b formula what? Log a minus log b. Log a minus log b. That is the formula here. So that value formula you converted to log a minus log a by b formula. Okay. We simplify the equation next. So n log gi n means n factorial log gi factorial minus log ni factorials. Okay. Ni factorials place is equal to place, that is the constant. So is a constant. So here constant is equal to so here is the value. Convert this formula. Constant equal to constant, that is the place here n factorial log gi factorial minus log ni factorial. Okay. So n is the factorial is equal to the differentiating. That is the you find out the differentiating differentiating. Which one is the differentiating? By differentiating differentiating delta is equal to delta log w is equal to minus delta summation delta summation delta summation summation n1 log n1 log n1 n1 log n1 log ni minus n1 sorry ni log log gi log gi log gi that is equal to summation is equal to here minus and not there that is our this minus so it come on the minus value so minus summation I minus summation I minus summation I log log gi by ni sorry ni by gi ni by gi so ni by gi ni by gi plus 1 plus 1 by g1 this is here formula this value here convert this one log a by b formula a by b formula so log a by b formula what here log a by b formula log a minus log b so that is to simplify this equation okay so that is summation delta 1 here 1 into delta ni factorial ni factorial so the probability to the maximum 1 minute only so there is a formula the probability to the maximum the probability to the maximum probability to the maximum summation 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 log ni by gi factorial plus 1 plus 1 delta ni is equal to how ni is equal to 0 అదే డోర్ తీసారా మీరు? అది ఉన్నారా వెళ్తున్నారా? ఉన్నారా వెళ్తున్నారు? ఉంటుందా? అది వెళ్తే డోర్ వేసుకున్నాను. సో summation log ni by gi plus 1 into delta ni is equal to 0. That is the simplify the log a by b formula. This is the value. Convert the formula. Okay. So that is the subject to the constant. Constant summation ni is equal to summation ni value is constant. That is constant. Constant. The summation delta ni is equal to 0. This value is equal to 0. Okay. So summation next summation ni gi is equal to summation ni ei is equal to g. Next summation delta ni ei is equal to 0. Ni is equal to 0. That is totally value is same. It is the total value is same. Okay. So that is a formula is substituting the formulas totally. You write summation ni summation summation log that this formula log ni by gi plus 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 alpha plus beta ei is equal to ei is equal to sorry is equal to beta ei ni is equal to 0. Ni is equal to 0. So that is the simplify here alpha beta ei the summation is convert to the 0 here. Convert the 0. So remaining log ni by gi plus alpha plus beta gi is equal to 0. Convert the something simplify that. So here ni by gi is equal to that is the formula, that is the value ni by gi is equal to minus alpha minus beta ei minus alpha minus beta ei. So here you convert the exponential value. So you find out the ni value. So ni value is equal to gi exponential of gi. Sorry, here you convert the exponential formula here. Ni is equal to gi exponential of alpha plus beta ei. Exponential of beta ei. So the classical there is the value factors is called the statistical weight of the beta alpha 1 by t. Beta, the one is that the factor is statistical weight of the I can sorry it can be beta alpha it can be beta alpha 1 by t. Beta alpha is 1 by t. So here beta is equal to 1 by t. There is formula is beta is equal to 1 by kt, not t, that is kt. that is kt. K is the here k is constant. K is constant. So we can the arrives that S is equal to K log S is equal to K log W. S is equal to K log W. That is Boltzmann relation. That is Boltzmann relation. That is that is Boltzmann relation. S is equal to the formula. The formula is important. Boltzmann constant is a formula, a relation to the formula. S is equal to K log W. So that is a value. So here Ni by Gi, therefore Ni by Gi for Maxwell-Boltzmann statistics is 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 1 by exponential 1 by exponential 1 by exponential 1 by exponential alpha plus beta ei. Alpha 1 by exponential alpha plus beta ei. This formula here. Okay, this one. So exponential the simplification as the result the e power of minus alpha is equal to minus alpha is equal to d is equal to d is equal to d is equal to d is equal to nh cube nh cube by nh cube by nh cube by nh cube by b into 2 pi m k m k m k 2 pi m k t m k t m k t m k t 3 by 2. That is it. E power of minus alpha is equal to d is equal to n nh cube by b into 2 pi m k t power of 3 by 2. That is you say. Okay. So here d is equal to that is d is equal to what? So nh cube by 2 pi mkt power of 3 by 2 and that's 3 by 2. So then the value d is equal to nh cube by b into 2 pi mkt power of 3 by 2. 3 by 2. So the 3 by 2. So here n1 ni by gi is equal to ni by gi is equal to you multiply the exponential total formula this. ఈ ఫార్ములాలో మీరు multiply the exponential value. Exponential. This one. Okay. So you are multiply this ni by gi ni by gi is equal to ni by gi is equal to 1 by exponential alpha exponential beta ei exponential alpha, exponential beta, beta ei is equal to what? Exponential minus alpha, exponential minus beta ei, beta ei. So here you multiply the summation, which one? Ni by gi, ni by gi, ni by gi into summation ni by gi, ni by gi, ni by gi, ni by gi, summation exponential of minus alpha, summation exponential of minus alpha, exponential of minus beta ei is equal to exponential of minus alpha, exponential of minus beta ei, exponential of beta ei. So here exponential minus alpha is equal to 1 by next here. Here exponential here exponential minus alpha is equal to 1, exponential minus beta vi is equal to 1 by j, 1 by j. Exponential f is equal to 1 comma summation here summation exponential of minus beta I is equal to 1 by j. That value, both values substitute here this formula. So here ni by here finally ni by gi is equal to 1 by j. 1 by j exponential of here 1 by j exponential of minus beta ei, minus beta ei. The distribution bi, the mb mean Maxwell Boltzmann statistics. The distribution function ni by gi is given by distribution function ni by gi is equal to 1 by j, 1 by j, this value 1 by j exponential of minus beta ei, minus beta ei. That is the Boltzmann, that is the formula. Okay. That is the Boltzmann is the formula. So z is the partition function. Z is here, z is partition function. That is the partition function. Z is equal to the partition function. Z is equal to exponential of minus beta vi. That is equal to partition function of exponential minus beta vi. That is our summation. So this is the partition function. What is the function for the given the system, the average number of the particles given the system, the number of the system, a particle is the decreasing exponentially with the energy EI, with the energy EI, this one energy EI of the level I, of the level is I, small I, the lower the temperature T, lower the temperature T, this is T. So this total values. This one here amount. This is a T, this is a T. Okay, T, lower the temperature T, the rapidly is the rate of the decrease. That can be essentially that derive the number of the ideal state, derive the number of the ideal state energy if follow the function, follow the function to be equal to, 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 to be equal to G into G, sorry, G into delta G is equal to delta E is equal to delta E is equal to 4 5 MB, 4 5 MB by 4 5 M, 4 5 MB by H cube, H cube, H cube, H cube 2 mg, 2 mg power of, power of 1 by 2 delta G, delta G. This is the delta is energy range. The G into delta is energy range. This is delta is energy range. G into delta E, G into delta is ideal state in the energy range. Ideal state in the energy range. The function to energy range G and E plus delta E. Delta E, delta is what? Delta is energy range. Energy range G into delta E is, delta E is ideal state in the ideal state, ideal state, the energy range, energy range, energy range E to E to E plus dV, E plus dV here. So this is Maxwell Boltzmann statistics. This is very very important question. This is a 10 marks question compulsory సార్ క్వశ్చన్ అండి. అంటేనా ఇది సప్లీలో రాలేదు పోయినసారి, ఈసారి కంపల్సరీ వస్తుంది క్వశ్చన్. ఓకేనా, కంపల్సరీ అంటే కంపల్సరీ అంటే క్వశ్చన్ అయితే ఇంపార్టెంట్ అండి. సో నెక్స్ట్ క్వశ్చన్ Maxwell Boltzmann distribution of velocities. Maxwell Boltzmann distribution of velocities. This is also important. ఈ 2 క్వశ్చన్ లో మాత్రం కంపల్సరీ క్వశ్చన్ అమ్మా. Maxwell-Boltzmann distribution of velocities. This is also 10 marks. Student class only 10 marks question. Okay. So compulsory question this one. This is also before question. This question is compulsory. Is one question is compulsory. It came with your exam. Okay. No? So here Maxwell derived the distribution law. Maxwell derived the distribution law of the velocities of molecules. Velocities of molecules using the MB distribution. MB mean Maxwell Boltzmann. Okay, na? MB mean Maxwell Boltzmann distribution laws. The Maxwell-Boltzmann distribution law is given by is MB distribution law is given by dn dn is equal to nc exponential of minus e by kt e by kt into dx dy dz. Maxwell MB distribution law is given by dn is equal to nc exponential of minus e by kt into dx dy dz. That is dx dy dz comma d dx dy dz dpx dpx dpy dpz dpx dpy dpz have the substituting as the substituting we have substituting beta is equal to 1 by kt. Beta is equal to 1 by kt comma c is equal to 1 by v v into 2 phi m k t for of 3 by 2. Substituting beta is equal to 1 by kt, c is equal to 1 by v into 2 phi m kt for of 3 by 2. 3 by 2. So that value that's substituting this one. So dn is equal to nv exponential of minus e by kt d into 2 phi mkt power of 3 by 2. dpx, dpx, dpy, dpz. So that is the value. You have considered that dn is equal to n into exponential of minus exponential of minus 3 by kt by, that is the value, dx, dpy, dpz is equal to 1. So that value is equal to 1 means v into 25 mkt by sorry, power of 3 by 2. That value like this. Okay. So here is 1 by dx, dy, dz. So here, for example, you since triple integral of dx, dy, dz is equal to v. This is CLD. So that value right here, both values this. This is equal to, here you write the formula. Okay. So that is the formula. Convert the formula. So similarly, n n by n by n by 25 m k t power of 3 by 2, 3 by 2 exponential of minus e by kt minus e by kt, this value minus e by kt exponential of minus e by kt dpx, dpx, dpy, dpz, dpz is the known as the translation energy, known as the translation energy, translation translational translational energy ke is equal to ke ke is given by, sorry, ke is given by k is given by k is given by v is equal to 1 by 2 to m, 1 by 2 to m x dot square plus y dot square plus z dot square. 1 by 2 m into x dot square plus y dot square is equal to m. That is equal to, px square plus px square plus py square plus pz square is equal to p is equal sorry is by px square plus py square plus pz square by which one, 2, you multiply this 2, yeah, you write this, है ना. Here x square y square plus z square value is px square plus py square plus pz square by multiply the 2 m. It is the value. So here px is equal to sorry, px is equal to m x i dot is equal to x i dot dpx is equal to m dpx is equal to mdx dot mdx dot mdx dot. The dn is equal to here first formula, dn is equal to n into dm is equal to n into m by 2 phi n by 2 phi k t power of 3 by 2 exponential of exponential of minus m into x dot square plus y dot square plus z dot square by 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 2 kt 2kt into dx dot dy dot dz dot dz dot is the velocity of range is the velocity of velocity of range then x dot x dot 2 x dot 2 x dot 2 x dot 2 x dot plus dx dot so here the velocity of range x dot to x dot plus dx next to y dot to y dot plus dy dot z dot to y dot sorry z dot plus dz dot z dot that is the velocity of range as the c is the speed of the molecules c is the speed of the molecules c square is equal to c square is equal to c square is equal to x dot square molecule of which one speed of the molecules speed of the molecule is the c is the speed of the molecule that is c square is equal to x dot square plus y dot square plus z dot square that is the polar coordinates that is the polar coordinates dx dot polar coordinates this is that is polar coordinates some polar coordinates dx dot dy dot dz dot polar that is the polar coordinates dx dot dy dot this one dx dy dot dz dot that is the c square is equal to what that is equal to c square which one c square sin theta d phi sin theta d theta d phi into c that is a formula polar coordinate is a formula dx dot dy dot dz is equal to c square sin theta d theta d phi into dc, sorry, dc. Okay, so that is the substitute in the equation. This is the substitute in the equation. This one dn. This is the dn formula. So you substitute that one. So here dn is equal to n into m5 n into m5 2 phi kt 2 phi kt 3 by 2 3 by 2 3 by 2 minus minus mc square. Which one? Why are you using the here c square? You write the this c square value. What is x dot square plus y dot square plus z dot square? That is the value. Here mc square by 2 kt into here dx dy dz dx dy dz dx dy dz value which formula? This value. Which one? dx dy dz is equal to what? C square sin theta d theta d phi and dc. That value substitute here above equation. Above equation. So you write that one. So dn is equal to so dn is equal to this formula. This formula dn is equal to total value here only this. You are observe this one. This is equal to c square. Okay, this is equal to c square. Which value is c square here? C square is equal to x dot square plus y dot square plus z dot square is equal to c square. That value substitute here. Next to dx dot dy dot dz dot. That is equal to what? Sin square c square sin theta d theta d phi and dc. So that value you are substitute. Okay. So next to dn is equal to n into m5 by 2 phi kt power of 3 by 2 exponential of minus mc square by 2 kt dx dot dy dot dz is equal to what? This. Substitute this into c square sin theta d theta d phi dc dc. That's the equation. So through the equation, the number of molecules which the speed between the speed molecules with the speed between the c and c plus dc, speed between the speed between the c2 c plus dc c2 c plus dc in the direction of line within the angular range angular angular range angular range. Which one angular range value? Theta theta 2 theta 2 theta d theta theta d theta. The number of molecules at theta 2 theta d theta plus comma 5 to 5 to 5 to 5 plus d5 5 plus d5 5 plus d5 5 plus d5 are given the number of molecules between the velocities, between the velocities, between the between the between the velocities, 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 between the velocities c and c plus dc, c and c plus dc, c plus dc, the respective of direction r is given by direction r is given by dn is equal to dn is equal to dn is equal to 4 5 4 5 n m 4 5 m n m 4 5 n 4 5 n m by m by m by which one 2 5 kt 2 5 kt for of 3 by 2 3 by 2 for of 3 by 2 3 by 2 exponential of minus exponential of minus exponential of minus this one mc square by 2 kt mc square by 2 kt 2 kt 2 kt 2 kt c square c square c square dc. Sorry for example, this is dc d the total this is equal to dc value. Okay, so dc the expression is the known as the Maxwell-Boltzmann distribution law of speed of the molecules, speed of the molecules, speed of the molecules when c is small or sir c is small c is small c is small the exponential minus m minus mc square minus mc square 2 kt 2 kt power of 3 by 2 3 by 2 3 by 2 is unity and the number of molecules unity of the number of molecules directly proportional to c square directly proportional to c square. So you write that one. You know directly proportional to c square. When c is large, exponential minus mc square here. Of here c small is here the proportional to c square value. C is large. C is large. C is large. Which one C is a large value? C is large. Exponential, exponential, exponential minus mc square by 2 kt 2 kt power of 3 by 2 power of 3 by 2 3 by 2 dominates over the c square dominates over the c square and c square and dn c square and and d d square sorry and dn dn alpha exponential of dn alpha exponential of minus c square by 2 kt 2 kt 2 kt 2 kt. That is plotted to against C that dn is increasing. dn is increasing. dn is increasing. The first probability is reaches the maximum value. It reaches the maximum value. The decrease is the exponentially is zero. The decrease in exponential is zero. So that is equal to dn by that is equal to dn by n. dn by n that is equal to dn by n is given the fraction of the molecules. dn by n is the fraction of the molecules. Fraction of the molecules. Fraction of the molecules between C and C and C and C plus DC. C and C plus DC. So now is the probability that molecules probability that is the molecules process of the speed between the speed between the this value C and C plus DC. C plus DC. Okay. So here W into C, W into C, W into C, W into C, DC, DC is equal to DC is equal to 4 pi m by 2 pi kt 2 kt sorry 2 pi kt 2 pi kt 3 by 2 m by 2 pi kt 3 by 2 exponential minus mc square by 2 kt 2 kt 2 kt which one 2 kt c square dc c square dc. So the probability molecules process to the speed is given by w of c w of c w of c is equal to w of c is equal to 4 5 4 5 4 5 m by 2 5 kt power of 3 by 2 exponential of mc square by 2 mc square by 2 into c, that is c is equal to c dc is equal to dx dy dz, that is value that is equal to 1. So you write that dc is equal to 1. So that is the converted formula. You write 4 5 m by 2 5 kt power of 3 by 2 exponential of minus mc square by 2 kt power of 2 kt into c square 2 kt into c square into c square. The kinetic energy here the kinetic energy ke is equal to the kinetic energy ke is equal to ke is equal to ke is equal to what k is equal to half m of m c square of mc square. So that is the formula. Substitute this one. E is equal to k E is equal to half mc square. So 2mc is equal to convert the derivative 2mc 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 DC is equal to DG. DC is equal to DG. So that is the integration. We converted to the 2MC DC 2MC DC 2MC DC is equal to DG. That is C square. That is C square C square C square DC C square DC C square DC is equal to DG. That is C. C square DC is equal to DG. That is C. So if the value C square DC is equal to 2e power of 1 by 2 dg by m into dg by m power of 3 by 2 power of 3 by 2. So here dn value, the expansion, the value dn is equal to 2 phi n by 5 kt, capital 5 kt 2 phi n by 2 phi, this is capital 2 phi n by 5 kt 5 kt 3 5 kt 3 by 2 5 kt 3 by 2 into e power of minus minus e by kt e power of 1 by 2 dE power of 1 by 2 dG is given number of the molecules, that is kinetic energy, given molecules with kinetic energy between kinetic energy between G and G plus DG plus DG and E plus DG plus DE. So E plus DE, the number of the molecules, is the direction is called the Maxwell-Boltzmann statistics. The distribution of energy energy C curves energy C curves C curves C curves C curves n of C n n n of C by n naught n of C by n naught n of C by n naught. C as the shape of the figure. So for example, this is the diagram. You are observe that is here. Okay. So here what CM, here is CP, CM, CR, there is CP, CM, there is CR, that is T2 greater than T1, greater than T1, that is the T2 greater than T1, Here we take the value n of c. This value we take the axis. Y-axis we take n of c by n naught value. Here which one? C value. This is c. Okay. Here we take the x-axis c. The y-axis there. Which one? N of c by n naught. So that is your diagram. So energy state, energy is c and torus n of c by n naught. Okay. So that is the value. All the temperature, as the temperature increase, that becomes planted with the more molecules requiring higher speed. Now the most probable speed CP, probable speed, probable speed, probable speed, yeah, CP, probable speed is CP is equal to CP is equal to Cp is equal to what? 2 kT by 2 kT by 2 kT by m 2 kT by m what? 2 kT by m by 2 2 2 kT by m power of 1 by 2. That is mean the mu m is given. That is the mean speed of mu m is equal to 8 kT. Here is 8 kT by m by m 1 by 2. That is RMS method. Okay. The here is usually CRMS. That is the RMS speed is given. CRMS is equal to is equal to is equal to which one? CM. The observe the CRMS greater than greater than greater than CM greater than CP. Okay. So this is the number of the molecules. Mean speed, the ratio of this is ratio of what? RMS value, CM value, and CP value ratio. Which one? 1.2 1.224 sorry ratio 1.224 and 1.128 is to 1.1 1.1. That is the respectively is the natural Boltzmann distribution of velocities. This is the question. You know, it's a very important question. 10 marks question is compulsory question. This one. Okay. So okay, Andy. Time is over. Okay. Thank you.
Sir,
You know, this is a compulsory question and 10 marks question. Please, anybody?
sir, linear harmonic oscillator also in Boltzmann, sir.
Which
Is
one?
this also important, sir? Next topic.
Boltzmann
6.2.
that is not important. Only 2 questions is a very, very important. Compulsory question one question is came your exam.
Okay, sir.
ఇప్పుడు
Thank you,
చెప్పినా
sir.
కదా 2 questions.
Okay, sir.
ఆ 2 లో కంపల్సరీ 1 క్వశ్చన్ వస్తుంది ఎగ్జామ్ లో.
Okay.
ఓకేనా?
Thank you, sir.
ఓకే, థ్యాంక్ యూ అమ్మా.